When you press the play button on Netflix, you might think that video streaming begins transmitting at that very moment. Actually, it doesn't. By the time you hit play, Netflix may have already completed video encoding, predicted which content will be watched, and even replicated the video to a server close to you. This is also why Netflix can handle millions of concurrent video streams without overwhelming its servers. So, how does Netflix actually do this? Suppose you were to build Netflix from scratch. How would you solve this problem? The most straightforward architecture would be to store videos in a few large data centers and place a CDN in front of them. When a user requests a movie, the CDN first checks its cache. If the content isn't in the cache, it fetches the video from the origin server, caches it, and then delivers it to the user. For a small website, this design is sufficient. But Netflix is not a small website. Suppose 65 million people are watching the same event simultaneously. Each video stream requires about 5 megabits per second of bandwidth. That adds up to over 300 terabits per second. At this scale, the problem is no longer whether servers are powerful enough, but rather, where's all this data going to come from? Moreover, if a highly anticipated new season drops at midnight, millions of people may hit play within minutes. But the CDN doesn't yet know the show is popular. The new episodes haven't entered the cache yet. So most of those millions of requests miss the cache, and the requests are sent back to the origin server. The cache only starts warming up as traffic arrives, which is actually the reverse of what we'd want. How does Netflix solve this? Netflix built its own content delivery network called Open Connect. Netflix deploys Open Connect appliances inside or near ISP networks, as well as at internet exchange points. This means the video doesn't necessarily have to travel all the way from a distant cloud data center to your home. The video is stored much closer to you. But this step is still just a CDN. What's truly interesting is, when is the video placed there? Netflix doesn't wait for users to request the video before filling the cache. It predicts demand in advance. Suppose a new series is launching on Friday. Netflix already knows this series exists. It predicts that a large number of people will watch it. So before Friday night actually arrives, Netflix can pre-stage this content and distribute it to the Open Connect servers most likely to need it. Think of this as a timeline. Thursday night, predict demand, prepare the video, replicate it to the right servers. Friday midnight, millions hit play, and the video is already there. So the cache isn't warming up after traffic arrives. It's already warm before traffic arrives. This is a fundamentally different architectural philosophy. This also explains a very important design in Netflix's infrastructure. When you press play, the content may not come from a single place. There are actually two parts, the control plane and the data plane. The control plane handles things like authentication, metadata, recommendations, playback info, and deciding where your video should come from. These requests can still go back to Netflix's backend infrastructure. But the video itself, a movie or series, may contain several gigabytes of data, so Netflix tries to keep this data as close to the user as possible. Conceptually, the request flow might look like this. Your device asks Netflix, where should I get this video from? Netflix returns the information needed to start playback. Then the actual large-scale data transfer begins from the Open Connect server that is closer to you. So the overall architecture looks more like this. The control plane makes decisions, and the data plane moves the data. At this point, Netflix has only solved half the problem. Because even if the video server is placed inside your ISPS network, the network inside your home can still be very poor. For example, someone is on a Wi-Fi video call, another device is downloading a large file, or the Wi-Fi signal simply weakens. Your available bandwidth may change every second, and Netflix cannot control these things. So it needs another mechanism, adaptive bitrate streaming. Netflix encodes the same video into multiple quality levels. Different resolutions require different amounts of data. At the same time, the video is chopped into small segments, and the player downloads one segment at a time. Before requesting the next segment, the player can observe the current network conditions and the amount of video buffered. Then, based on this information, it decides what quality to use for the next segment. If the network is fast and stable, it gradually increases the quality. If the network becomes unstable, it lowers the quality. Netflix sacrifices a bit of visual quality in exchange for smooth playback continuity. Now, combine these two mechanisms. The first mechanism solves what happens before the video reaches the user. Open Connect places content closer to the user before demand actually arrives. The second mechanism solves the uncertainty inside the user's own network. Adaptive bitrate dynamically adjusts the amount of data the video requires as network conditions change. One mechanism reduces distance and congestion. The other absorbs the remaining instability. Put them together and you'll see that what Netflix is really doing is more interesting than just deploying a giant CDN. It is essentially moving expensive work to happen before the user ever notices. Netflix's approach is closer to predict, pre-compute, pre-distribute, and then wait for the request. When the request finally arrives, the system has little expensive work left to do. This is a very powerful idea, because in small-scale systems, it's perfectly fine to handle things after demand appears, but at massive scale, waiting until demand arrives to start processing may already be too late.